model, which then interacts with Microsoft Azure resources behind the scenes. So what you saw me create a VM in the portal, you've seen me create a VM using PowerShell. All of that stuff had the same back end in terms of how the resource eventually got created. Now we can see this in detail because the ARM model is basically running on JSON templates for the files that go to power that. So I'm going to get this out of the way here. Now when I create a virtual machine or any resource in Azure, oftentimes at the end of that process, before I hit the create button, I can see a link that says download a template for automation. This is not the only way to get this template, but this is one way that we're going to basically see behind the scenes to what Azure is actually going to deploy. So I'm going to click this download a template. So this has changed over the years, but the basic version is there are two main files to create a resource or set of resources. That is the template file and the parameters file. And like I said, these are in what's called JSON format, JavaScript object notation format. That means that the files are kind of readable and also machine readable, human readable and machine readable. So I'm going to, instead of reading them here in the browser, I'm going to click this download button, and this is going to bring the ARM template into my local machine. Now I'm going to take these files outside of this zip, and we're going to open them inside of a text editor. All right, hopefully this is readable for you. Now this JSON file, it can be quite long depending on how many resources you're creating at once and all of the complexities. A virtual machine is one of the more complicated resources to create with all the parameters. And so we're going to see here this file actually can tell you it's 560 lines. So it's quite a long template just for a virtual machine. So if we look at an empty ARM template, we can see that there are 6 properties of the ARM template at the top level. So the first property is this $ schema, and the value is a fixed string. So this is always going to be this URL with this 2015 or 101. Content version is allowing you to version your ARM templates. The purpose of this is so that you can keep track of when you're on version 1.1, 1.2, 1.3, which is the most recent version of this template. You can then be able to store that in a source code repository like GitHub or whatever you use for storing your source code, and that's called infrastructure as code. And so we can basically define our Azure infrastructure as a file, store that in our source code repository, and always have a copy of the latest version of our infrastructure as this JSON file. Now the 4 elements of the ARM template beyond that are parameters, variables, resources, which is an array, and outputs. Now parameters, as we saw, are going to be these variables that can be passed into the template. So the purpose of this template is automation, and an automation would not be useful if you couldn't pass in parameters. That because all of the values would need to change the name of the VM, the location, any of those values that could be passed in. If we look at the parameters of the VM that we just tried to deploy, we didn't actually hit the create button. There are, dozens of parameters, and they have everything to do with the location, the network interface name, the security group name, these port rules like allowing port 3389, subnets, virtual networks, addresses for the virtual networks, public IP address. All of the variables that can be passed in can be a parameter. Now, of course, this could also be hard-coded if that's convenient for you. It's very flexible in that way. Now you'll see, and one thing in particular I'll point out is that it's passing in the username that I created, but it's not passing in a password. So I'm going to have to, before I deploy this, set this as a password. I wouldn't obviously do this on video, but notice that it's not violating my security by letting me download this text file with my password in it. Variables are basically parameters, but they come from inside. They're not coming from outside. So if we go look at a variable, it's basically an important element is the resources, and this is an array. This the shut. All right. So what I want to do. So let's have a look in a little closer detail. The contents of this resources section. This really is the powerhouse of the ARM template and what is doing the work. Now maybe the network interface cart is not the first place to start, but we can see that a network security group is being created here. We can see that it's got a name, and that name is being passed in through a parameter. We can see that it has a type. All resources. So let's have a look in a little closer detail. The contents of this resources section. This really is the powerhouse of the ARM template and what is doing the work. Now maybe the network interface cart is not the first place to start, but we can see that a network security group is being created here. We can see that it's got a name, and that name is being passed in through a parameter. We can see that it has a type. All resources have type. Most of them have names in terms of Microsoft.network/network security groups. Now you don't need to know this wording for the test, but it will help you to be able to look at this and kind of understand what it's trying to do. Like I said, it is supposed to be a human readable format. We don't need to worry about the API version, but we can see that the network security group is going to be deployed into the same location, which is the default location that was passed in as a parameter. And finally, in order to create the network security group name, we need to create a network security group rule, and the rules are a separate parameter. And so if we go over to the parameters file, we can see that network security groups rules is an array. So there's a value and it starts with a square bracket. That's an array. And really the only rule that's being passed in is the RDP port. We want to allow TCP port 3389 inbound from all source addresses to all destinations on the network. Obviously this could be quite restrictive if you wanted it to be, but it's an example of a network security group rule that's just being passed in as a parameter. So this single resource, if I was to copy that, put this into our empty template here, this would be enough to create a network security group. And if that's all you needed to do, I would have to hard code. Let's hard code the network security group name. So there's the string for that, and the location. There's a string for that, and the security group rules. And as we saw, that's an array, not a string. This alone would be enough to deploy a new network security group into Azure if all I did was do this. So you can see that these templates do not have to be complicated if you don't need them to be. So going back to the template, we can see that the virtual network, which is VNet, that's also can be quite simple. It's got a type, a name, location, and the properties are going to be the IP address range and the subnets. And in this case, it's just the default subnet, I suppose. If we go down into here, we can see the subnet name comes in as default. The address prefixes is an array. So it is worthwhile for you, from an exam perspective, to at least be able to look at this and go, okay, I understand where that's coming from. I understand where that's coming from. Knowing the portal, this is the minimum required to create a virtual network, right? All of those other things are optional, are not part of the creation process. Public IP address, right, has a name, has a SKU. There's the allocation method. So just being able to scroll through this file, read the types, understand things like depends on. So this resource would not be deployed until these other two resources have been successfully deployed. So that's how it knows not to do the one thing before the other. So in this video, we're actually going to modify this ARM template before deploying it. Now I thought about what I want to do in order to modify this, and I think what I'm going to do is I'm going to basically not deploy one of the resources. So I've chosen the public IP address as being the resource that will not be deployed. We're not going to have a public IP for this virtual machine. It'll only be a private IP address. So I can choose this whole section that is a public IP address, and I can click delete. And I'll even take away the blank line. Now, what are the implications of not deploying the public IP address? Well, there actually is a dependency. So if we go up to the network interface card, we can see that public IP address is one of the dependencies. So we just have to remove that as a dependency, as it'll never be created because it's not part of this file anymore. So now we've removed it as a dependency. The next thing we have to do is we have to remove it as a parameter. So under the network interface card properties, we have this public interface, public IP address that's under IP configurations. So I'm going to actually remove the public IP address attached to the network interface. Okay. So if I make sure my curly brackets, there's 2 opens and 2 closes, then this virtual machine network interface card will not have a public IP address attached. So that's pretty straightforward in terms of modifying this. Now, this can get quite complicated, obviously. So if I wanted it to have 2 public interface network interface cards and attach both interface cards to the same VM, there I can copy the section and I can set that up in the various sections of the resource management template. But I'm just going to keep it simple for now. We've removed the public IP address. So I think I've saved this. It's on my local. And I think what we're going to do is we're going to try to get these resources deployed into So we're back in the portal. We've downloaded the templates and the parameters file to our local, made some changes to it. Now what do we want to do? Now we could save the template that Azure downloaded to us to what's called a template library. We could schedule this for deployment right from the screen as well. But we've modified this template, and so really what we want to do is we want to create a new template in the template library. Now the other thing I should point out is there's the PowerShell and CLI scripts that can be used to deploy the template. Now it's pretty straightforward. It's a single a single PowerShell command. So if I said new -az resource group deployment, that is the command that's going to set the ARM template and the parameters file out to be deployed. But we're not going to skip ahead. What we're going to do is we're going to cancel out of this creating of a virtual machine and go to the Azure Portal Home. Now I'm going to go into the search box and I'm going to say template. Now Azure has recently introduced a new thing called template specs. Templates still exist. If I go into templates, now I've never used this before on this subscription. My other subscription has lots of templates to show, but it says in the headlines templates will be retired after March 2025. And so we recommend converting your existing templates to template specs, which makes it easier to share and link templates. So we'll go into template specs, and we can see a couple of options. We can create a blank template, and then we can just copy and paste our template, or we can import a template. So ARM Manager template file, and there's this little folder icon. I can select my template file and say import. So the template body has been populated with imported content, but some additional fields must be provided. And we can see here that the resource group is one field that was not part of the original template, but we should provide. And so I'm going to call this VM ARM demo. Location was already part of the template, and we can give this a description. And we can version this, and so there's basically, we can use version 1.0, and this is sort of a brief demo. It can be very detailed or not. Next, we'll be able to see the template that we're importing, and we can actually see that the IP address, so if we look at the NIC card, virtual machine, probably it's up here, we can make further. Great. A resource, and that resource can then be shared. You can set permissions on this and things like that. You can see the template specs. If I go into the ARM, the resource group, and I say show hidden types, we can see the template spec is now stored as. So now we have a template that can then we can do things to. And one of the things we may want to do is obviously deploy this template. So we're in the template spec resource, and we can create a new version, we can edit it, and we can are empty. And there is no import parameter file option into it. So quotation create. The name C. Now I'm going to stop and ask you a question here. What do you think would happen if I was to deploy the same ARM template again? That is, we have a resource group that has all of the resources running inside of it, the VM, the network security card, and all of these things. But I was to run the same process that we just went through a second time. Would it fail? Or would these resources be destroyed somehow, or what would happen? Well, in actual fact, when you do an ARM template deployment again, it skips over resources that are already existing and have the same properties. So the same disk created with the same name, with the same settings, would actually just get skipped over. And so none of this would be, in fact, redeployed. To show this, I'm going to actually delete this virtual machine. So I've got the VM that we just created with this ARM template, and I'm going to hit delete just on the VM. Now, the network interface card in this case will not get deleted. The operating system disk will get deleted. I'm okay with that. That's 2 resources that are going to end up being deleted out of the 8. I'm going to say okay. So we'll give that a few seconds to delete. Now, what I'm going to PowerShell underscore play file to. So this, if I do it again. Now I'm going to use the new -az resource group files. IntelliSense here, predictive IntelliSense, but I'm not going to use it. So I can paste in the command into the same resource group with the close basically into the deployment. So we're wrapping up this section on ARM templates, and we've seen specs in the deployment. Say you are deploying it every 6 hours. ARM template for Gene. So this is the VM here. Now this VM is a standard V1S, right? A very small VM. Let's say I was going to the size setting. Behind the scenes, this is using ARM to make this change, but it's not actually deploying an ARM template, but it is using the Azure Resource Manager model to communicate with the virtual machine. Deployments. First, you'll notice that the resize did not get stored as a deployment. So that any kind of settings change that you do is not actually going to be captured as a deployment. And the second thing is, if we go into one of these deployment files, we can see what happened, we can see how long it took, and we can see the templates. So here is the template. But what we don't get, so this is the parameters, and what we don't get is we don't get the new options. So if you make a made, sure the current state settings of that virtual machine. In the Azure portal is create a brand new ARM template based on the new settings of that virtual machine. Now this is not on the exam, but I should mention that there are other ways of dealing with resource automation besides ARM templates. Microsoft has a public open source way called Bicep. Now Bicep is a language that turns it easier to understand language and template. There are also other alternatives like Terraform that can be used to create resources in Azure. Okay, so they're not the only way of creating resources using ARM templates, but other resources. Now, one of the challenges to deploying virtual machines, as opposed to Azure Web Apps, for instance, is getting your code set up and running on the virtual machine. And so let's say you're using an ARM install post-deployment action. GitHub, scroll down a little bit to the resources section. We can see there's a public IP address, a virtual network, and a subnet. There's the network interface card. Now again, if we were just to deploy this as is, you would end, which is this type, Microsoft.compute/virtual machine/extension. What you do is you pass it the location. The other alternative to having a VM that is ready to go as soon as you instantiate it is to use an existing VHD. So here's an example of an ARM template, again from the Azure Start templates, that says specialized VHD. And if we scroll down here, I'm going to pass things to here. You are create a VM. All right, we're moving on to talk about virtual networks. Now, virtual networks I view as the glue that tie various infrastructure as a services together. And we've seen so far in this course that virtual machines absolutely require a virtual network in order to have connectivity to the internet, to have connectivity to each other and to other Azure services. And you have the option within things like app services to connect to a virtual network to allow some control over routing and security and things like that. So in this video, we're going to create a virtual network, and we're not going to like when we create a virtual machine, it allows us to create a virtual network at the same time. We're actually going to intentionally create a virtual network from scratch. So you can go into the marketplace and search for virtual networks or VNet, and you'll get to something like this where you can say create a virtual network. Now, like anything, we have our wizard view of creating this virtual network. I'm going to create a new resource group to put this in. And we're going to have to give it a name. Now, the region of the virtual network does matter because you're going to be restricted to the virtual machines being from that region to add it to the same virtual network. There is a relationship between the location of the network and the location of the computing resources. So I'm going to choose West Europe to put this network. That restricts me from only putting VMs from West Europe onto this network. Then I'm going to click Next. Now they've moved this around a little bit. The next tab is Security. So there are a number of services that you can add to your network, and these are paid services. So if you want to have Azure Bastion, we saw that earlier in the course for RDP SSH connectivity to virtual machines without having to open the ports. We have an Azure Firewall option. We haven't talked about firewall yet. DDoS protection. And if you were to check any of these services, then you would have to, you're basically provisioning that service. So by checking Azure Bastion, it's going to ask me for the host name, and it's going to create a new public IP address for Bastion. Similarly, for firewall, we then start up the various firewall options. We're not going to do that. But there's an interesting side effect I'll show you in a second from me selecting these and then unselecting it. When we go on to looking at IP addresses, this is quite important, right? So the IP address range of a virtual network can be changed after you start with a number of private IP addresses that are available for use, and then you can again add to it if you need more. This space here, this 10.0.0.0/16, that's called CIDR notation, CIDR, and it's a bitmap, basically a mask that will allow you to determine how many IP addresses are in this range. And we can see a clue underneath where it says 10.0.0.0 to 10.0.255.255. So this /16 basically is a mask over the first 2 octets, and then the other 2 octets of this are the full range. If I said /24, then you would only have 256 addresses available. And if I said /8, I would have, the full 3 final octets available. You don't need to make this too big, like 65,000 addresses means 65,000 virtual machines, which is quite a lot. By default, you get a subnet called default. Notice the subnet is smaller than the total addressable space for the VNet. So by default, I'm giving it /24, which is, like I said, the 256 addresses. That leaves tens of thousands of other addresses that I could allocate with other subnets. Because I selected Bastion and Firewall on the previous screen and then unselected them, Azure is helpfully allowing me to create 2 additional subnets for those. And as you can see, it is 2.0.1 to 63 and 2.0.2 to 63. So we're actually wasting 3/4 of this part, this D block, I guess. So we can see here it's done some helpful things for us. Now, typically what you do with subnet is you want to divide your network across security zones. So you might have a subnet for front-end websites, a subnet for databases, a subnet for middle-tier applications, etc. So each subnet can be secured differently using a network security group. If we wanted to change this, we could add an address space. If we wanted to add additional subnets, like we had the middle tier and the back end, we can add a subnet. I'm not going to do that right now. We'll add the subnet later in this course. So I'm going to accept the defaults, including the Bastion and Firewall subnets, not including those services. We'll skip over the tags, and we'll get to the validation element. Now, virtual networks are free. There's no charge to create them at this moment, but you are limited in the number of virtual networks that can be associated with your subscription. I think it's 250 virtual networks per region. So don't go absolutely crazy with creating them, but you can create many, many of them and not worry about racking up any charges until you create resources like a virtual machine attached to it. So I'm going to click the Create button. We'll let that run. Now, this took only a couple of seconds, and I think the reason is because there's not actually resources being instantiated when you create a virtual network. You're really just, it's really entries in a database table. Microsoft has the 3 subnets, one your virtual network. So as you can see, we don't have any devices on our VNet. So maybe before we go any further, let's deploy a little virtual machine to this. So I'm going to create a Windows Server 2019 data center virtual machine. Just for convenience, I'm going to put it into the same resource group. I'm going to call this a VM demo. No infrastructure availability. Let's just leave it as a standard VM. This one is very small, B1S. I'm going to upgrade that to B2MS. And put a user ID and password. Just for demonstration purposes, I'm not going to open any ports. Okay, so let's assume that there's no ports open at this moment. We'll skip over the disk options and we'll get into the networking options. Now you can see it's chosen my VNet by default because I have one in that region. If I had chosen a different region, it wouldn't be available to me. It's putting this virtual machine into the default subnet But in this particular case, it's coming up with a brand new public IP. I'm going to say no to that. Okay. We'll let it create a network security group. We're not going to open any ports. So right now this machine will have an internal private IP address that starts with a 10 and will not have a public IP address. I'm going to skip over most of the next settings here. No diagnostics. Skip the advanced and get right into review and create. 10 cents an hour for this B2MS. Click create. So what I'm expecting is that it will deploy this B2MS machine onto this VNet, and we'll see.
I liked him first.
see that in a second. All right, so that was pretty quick. You can say go to resource. Machine is still starting up, obviously. Go into the networking settings for the virtual machine. And we can see the network has a network interface card, and the network interface card is attached to our VNet. Let's get out of here, go back into our VNet demo, and go into connected devices. And now we can see the network interface card is connected to our VNet using the following IP address. So it's an internal IP address on the default subnet. So this is exactly what we were expecting. And so in this way, we can create devices, deploy them into the various subnets that we create. These Bastion and Firewall subnets are obviously reserved for those Azure services. And in this section, we will talk about setting up the security, opening up ports, and restricting. Let's say we have a front end and a back end subnet. We'll talk about how to basically protect those by closing off ports. Now, just to further demonstrate this, I'm going to create a couple of additional subnets onto this virtual network. Now we can see that 10.0.0.0 is already taken, the full /24 range. 10.0.1.0 is only partly taken, about a quarter of the range, and the same for 10.0.2.0. So I'm going to create a, let's call it mid-tier subnet, and you'll see it's automatically offering me up 10.0.3. So these cannot overlap, and they must be sub-ranges of the total address space for the entire virtual network. We have the option of getting IPv6. All of Azure now supports IPv6 connectivity, and we can select any sort of gateways, any security groups, routing. We won't do that at this time, but we have a lot of advanced options. Now that's as easy as it is to create a subnet. We can call it back tier, and we get the 10.0.4 range and stay safe. So now I have 3 subnets that are from my creation. Now, one thing that's kind of bothering me about the inefficiency here is that we do have, I said, a subnet that is only using 59 or 64 effectively IP addresses out of a 256 address range and wasting the others. So what I'm going to do is I want to edit this firewall subnet so that it is on running beside this Bastion subnet, and we're not wasting potentially a space of range. Now, the reality is you don't have to be so thrifty with IP addresses in the private space, because there are millions of them, and you probably will never run out of private IP addresses. But maybe there's a little bit of wanting to be organized here. And so I can change my subnet range for the firewall. You'll see that this one, each of them have 64 addresses that they're asking for. So if I change this to 10.0.1.64/26, I'm actually reserving the next block of 64 next to the Bastion subnet, and I'm freeing up this 10.0.2 for another purpose. So I can even edit the range of a subnet as long as there's not other things running on it. Okay, to be clear. So if there is devices running on this subnet, then I can't just decide I want to change this to a different. Oh, let's put this in a new subnet range because my network interface card and other things have IP addresses in the old range. So be careful when you're renaming subnets that what's the downstream implications for devices that are running on it. So I won't touch the default, but we can leave the this as this, and you can see you're not restricted to this .0 ending. You can actually stack them quite nicely here. So right now we have a virtual network with some subnets. We have a virtual machine that has a network interface card connected to that subnet. Right now everything is set to private. There is no public IP address for this network interface card. What we're going to do in this video is we're going to create a public IP address and associate it with this network interface card, and basically we can then start to open up some ports and get some traffic. Now we could have done this all during the creation screen, but I think there's value here in doing this step by step to see how it works. So let's create a public IP address. So I'm going to search for public. public IP address. Now, public IP addresses are not free. You can see from the pricing chart here that for the ARM model, a dynamic address runs at 4/10 of a cent per hour. Okay, if we need to get a dedicated IP address, then that runs, which is static, that runs less than 4/10, and we can see based on the tier, it's going to have different pricing. All right, so let's go into the thing here. We're going to create a public IP address and say create. I'm going to put this into my VNet demo resource group. Now we can choose a region for that address. I'll keep this in West Europe. We give it a name, so usually it's like PIP something or other. We can choose whether we want a v4 address or one of those new fancy v6 addresses. As we saw, that the pricing does come in basic, standard, and global in terms of pricing. When we are on the basic model, we don't get the availability options, right? We don't have zone redundant or zoneless options. The basic is just basic. Typically, you would use a standard IP address with a load balancer, and in fact, you are going to find that sometimes you're forced into the standard SKU for that type of thing. It's a zone redundant, high availability option. Now, do I want this IP address to be dynamically assigned, or do I want an address that never changes, a static address? So I don't mind a dynamic address, so we're going to we'll create a DNS entry for this, and it'll be accessed by its name. Idle timeout, and the DNS name label, and this is where you're going to have a fully qualified domain name. So I can say something like that, which is going to be appended to .westus.cloudapp.azure.com, or in this case West Europe. So I'm going to click review and create. Once it does the validation here, it's clearly everything's okay, and I'm going to click create. Alright, so I'm going to say go to resource. Now the thing with a dynamic address, see I chose the dynamic option, the address itself is not going to get generated until I assign it to a resource. So I have almost like a reservation for an IP address. I have a name for it, and I'm going to have to assign this to a network interface card for the system to dynamically generate an IP address. The static IP address, again, like I said, it can be assigned instantly, and it doesn't change. And again, you have different tiers for a static address, etc. So let's pause the video. We'll come back. We're going to associate this address with our network interface card. So now we have this dynamic IP address that is yet to be assigned, and all we can do is associate it with the network interface card that will give the virtual machine a public IP address. So I click on the associate button within the public IP address. I choose network interface, and I can choose the network interface card right here from the drop-down list. Alternately, I can go into the network interface and I can add an IP address from within there. So there's two ways to go about this. So I'm going to click OK. Alright, so we successfully updated that. Now what I'm expecting, if I refresh this, I guess I could give it a moment to come up with it. We're going to go into the virtual machine here under networking. You can already see, we can already see that there's a public IP address that's associated with this network interface card. And it takes me back to this one that we just created. It now has a public address. Now, if I go to the network interface card itself, under IP configurations, we can see that the same basically network interface card has both a private address and a public address. So virtual machines on the same network can refer to this machine using its private address. And of course, publicly can be associated with this address. Now, keep in mind that the security is still enabled, and there should be really nothing that we can do if we try to ping this address or we try to remote desktop into it. Certainly, we haven't installed a web server yet, so there's nothing listening on port 80 or 443. The network security group should have really shut this down and not allowed any traffic to it. So there's a public IP address. Hopefully, there's really very little that can be exposed to the machine. Now, we have a whole section talking about securing access to networks, network security groups, effective security rules, and stuff like that. But just briefly, I will show you. We go into network security group, and it shows us here. Actually, we are going to have to go back up to the resource group, and we'll see network security group as something that exists. And if we look at the inbound security rules, basically we have a deny rule on all inbound traffic. The only traffic allowed is from the same virtual network or from a load balancer. So there should be no traffic allowed to this public IP address into this server at this time. So we saw in the last video that this network security group is attached to the network interface card that's attached to our virtual machine. And right now it does not allow any traffic in from the internet. Since we've assigned a public IP address to it, let's start by attaching or allowing RDP traffic to go to that virtual network. So I'm in the network security group under inbound security rules, and I'm going to say add. We're going to allow traffic from any store, so we could put our client IP address in here if we wanted to. And we are going to choose, for a shortcut, we can choose the RDP. RDP service, and it tells you port 3389 for TCP, and we allow the rule. Now priority, the lower number has the higher priority. We have to give it a name. We should give it a name that is, say, relevant to this. So allow RDP and say add. So now it's going to take a couple minutes to go into effect, but now the network security group is going to allow traffic from outside over this port onto the network. Now after a couple minutes of allowing this to sort of filter through, we can go right to the virtual machine and, like we did earlier in this course, go to the Connect menu item under RDP. It will check to see if we have access, which we should, now that we have the rule created for the network security group. And here we go. We have the RDP file at our disposal, and we should be able to establish a connection, which we have, right? So that's how, I would say, straightforward it is to create a public IP address associated with a network card, open up the rule, and then be able to connect to this virtual machine using the remote desktop protocol. Of course, you shouldn't have ports open on your network security group if you don't need them, and so this type of RDP port should be either very limited, you should use a Bastion server, or you should remove all of those types of open ports for security reasons. All right, so we have created a virtual network. We've attached a virtual machine to it. We were able to open some ports using the network security group that we could remote into the machine. We have a public IP address associated with it, etc. Now, next thing I want to talk about is the concept of user-defined routes. But in order to really demonstrate user-defined routes, we're going to need we have the source, which is the virtual machine, and we're going to need sort of a path for the traffic to travel through. And what I'm going to do is I'm going to create a firewall to demonstrate user-defined routes. But firewall is not part of this exam. You won't find firewall mentioned in even in the security section of virtual networks. It's not listed. Obviously, firewall is a big topic. It can be part of AZ 500 or one of those security SC exams. But on AZ 104, firewall is not mentioned. But I'm going to create it anyways. Hopefully you'll get some educational value from it. So let's create a firewall. I'm going to go into create a resource, and I'm going to look at firewall. Now we're creating a Microsoft firewall for Azure. Now firewalls have changed over the last couple of years. There used to be a firewall that had all of the rules that were part of the firewall itself, and it was kind of difficult to manage because if you had dozens of firewalls, you had to go into each firewall to manage the rules. Microsoft moved to more of what's called firewall policy method, so the rules of the firewall are managed outside of the firewall, and then they can just be associated with the firewall. Anyways, I'm going to create the old style of firewall called Classic, just because it's easier to create at this moment. So we're going to put this in my resource group. We're going to call this FW demo, and it has to be running in the same region as the network, of course, and the virtual machine. So I believe it's West Europe. Now, a basic firewall is required to use firewall policy, and even a premium firewall is required to use firewall policy. We're going to choose the standard firewall so that we can choose Classic. And like I said, the rules of the firewall are built into the firewall. We're going to attach this to our existing virtual network. We don't have a public IP address for this firewall, so we have to create a new one. I'll call it PIP2. Forced tunneling. So if we wanted to create an additional subnet for firewall management traffic, we're not going to turn that on. We'll leave that disabled for now. We can just go right to review. So you see part of the creation, there's not much detail being given. We're going to get a firewall. And we'll have to go into the resource and to set the settings. So we'll wait for it to be created. All right, so the resource was created. We can say go to resource. Now, one thing we need to do is the firewall is going to have both a public and a private IP address. So in order to create a route from the virtual machine to the firewall, and then from the firewall to the internet, we should make a note of the private and public IP addresses. So I will make a copy here. So here are the two IP addresses for the firewall. Just keep that to the side. Now, as it stands right now, the firewall isn't actually doing anything, right? We don't have any. We can send traffic to it, but we don't have any rules that are setting up how the firewall is going to handle the traffic. When the traffic is brought inbound to the firewall, we don't have any rules to say, oh, you're going to send the traffic anywhere else, and vice versa. When we have traffic from an internal server sending traffic to the firewall, we don't have that rule that allows the traffic to be redirected to the internet. So this is going to be the firewall rules that are going to allow the traffic in and out. And before we set up the firewall rules, let's go and create a user-defined route that is going to force traffic that's leaving the virtual machine to come to this firewall. We'll do that in the next video. So in this video, we're going to talk about something called user-defined routes, or UDR. So UDR in Azure allows you to change the default way that